Okay, good afternoon / good morning, everyone. Welcome to our webinar. We've got about 40 people in the room, and we have plenty to get going with. So I'm going to kick things off, and I'm sure we'll have more people joining. Yes, I can see people joining as I speak. So welcome to our webinar, Analyzing the Earth at Scale. Today, we're really honored to be joined by Google Cloud, and we're going to be talking all about how you can access truly, truly massive data all about Earth observation and remote sensing to help enrich your spatial analysis. A couple of bits of housekeeping before we get started. We have a Q&A and a chat that hopefully you can see. So if you do have any questions or anything at all that comes to mind, please do feel free to drop them in there and we'll probably get to them at the end. Like I said, we've got loads of content to get through, so if we don't have time to get to your questions, we will absolutely drop you an email afterwards. And the only other thing I was going to mention is if you have any problems hearing us, seeing our screens, anything at all like that, we have a fantastic moderator with us, so do drop that in the chat and we will do our best to fix that for you. So next slide, please. Let's kick things off. So just to introduce ourselves, my name is Helen McKenzie and I'm a geospatial advocate at CARTO. So my job is all about helping organizations realize the power of geospatial data and analytics and visualizations in a way that really works best for them. And Jenna, would you like to introduce yourself?
Yeah, so hi everyone. My name is Gennadii Donchyts. I'm work as cloud geographer at Google. So I work across geospatial services in Google Cloud. So nice to meet you, everyone.
Fantastic, thank you. So if you have any questions for either of us in particular, you can find us on LinkedIn here. Can we move to the next slide, please? And I'll just talk a little about what you've got yourselves in for over the next sort of 45 minutes. So first of all, Ganna's going to be talking all about Google Earth Engine and give you a real introduction to the platform, talking about use cases and integrations with Google BigQuery. Then he's going to throw things back to me, and I'm going to talk a bit about how you can access this data in a really straightforward, low-code way, and how you can really do that in a way that is really scalable. And then we'll throw things back to you guys and hear if you've got any questions or anything that you want to talk about. So with no further ado, Ganna, over to you.
Yeah, thank you, Helen. So first part, I'm going to talk about Google Earth Engine. And for some of you who worked with Earth Engine, this might not be a new presentation. But for those who never heard term or Earth Engine or never worked with it, this would be useful presentation, hopefully. So when you talk about Google Earth Engine, the first thing you should think about is if your goal is really to process large amount of imagery, could be weather forecast of weather analysis data or satellite imagery. And by large, you have to think about terabytes or petabytes of data. This is really where Earth Engine becomes a helpful tool. And Google, actually, it's not a new service. So we started developing more than 10 years ago. And it was available as a commercial service for a long time. But since a few years ago, we started offering it as part of Google Cloud. And there's a lot of integration going on to make this platform more available. But if you have this type of tasks that you want to automate large-scale image processing, and the task you can think of is, for example, when it comes to satellite imagery or weather data, it would be maybe multi-temporal processing. You would want to look at every image, compute cloud probability or different vegetation indices, compute this statistic across stack. So this is basically the pipelines that we run to generate Google Maps data, but also many other use cases. So that would be like one of the challenge to solve. But also, if you think about the file formats you have available for different types of imagery, if your task is really to gather maybe 10 different sources, gather imagery from 10 different sources in different file formats with all types of harmonization tasks with meta info stored in different formats. This becomes really very time-consuming task, and usually takes like most of the time before you really can start analyzing this data. And so what we did at Google, we basically tried to develop a platform to flip this pipeline, say, okay, we will do it once for public data sets that we would include in public data catalog, harmonize all these images across, so all parameters across all these data sets, and then basically give people a tool service where you could start really spending time on analyzing data and not just data wrangling and downloading all these images. So what Earth Engine in reality is that we try to create it, make it so accessible that you could use a web browser basically to process this large amounts of data, where you would write some code and really start kicking off some calculations on a Google site. And on a Google server side, we have a place where we store all this data, and we have also a large compute cluster, and all of this is wrapped by API. So it basically works as a service that can be, you can talk to it, and then it will do some calculation and return results on the fly. If you look at the data sets that we included in catalog, so currently it amounts, I think it's getting close to towards 100 petabytes of data, which we really, it's curated data sets that we selected. We heard from community requests that they are useful, and most of this data catalog is really public data sets. So you see here a few examples, but you could just click on this link in this slide, and then you can explore what's included in the data catalog. There's about 1,000+ data sets included, and we also have active community working on collecting different data sets. There are probably 3,000 data set more available there, and all of this is available for analysis via Earth Engine. And of course, all the platform works on, so we have cluster of tens of thousands of compute machines, but you don't have to do any parallel computing yourself. So basically what you would be using is a API, a high-level API, where you would be, we have about like 200+ functions that you can use to process this imagery, combine it with vector data, and really define different complex pipelines in just few lines of code. Sometimes involving machine learning tasks, sometimes doing like spatial temporal processing, computing spectral indices, or all types of image analysis at scale, or georeference image analysis at scale. To work with Google Earth Engine, you really have to code. So there we have a web-based platform where you could write code in JavaScript as a language, and then this is like main development environment. On the other hand, we have for data scientists, they typically would use Python as a programming language. So the API would be exactly the same. So once you learn one platform or another, you would be able to basically use it. So only the syntax of the language would change when you switch from one platform to another. And if you look at just showing few use cases, examples of let's say what you could do with the platform. So here you see that there's few lines of code where you can reference data set. In this case, it's SMIP6 data sets, which is contains forecasting of it's a climate projections from about 100 different models. So typically you would select data set, filter maybe by different parameters, images, so maybe going from millions to just few thousands of images, and then you would apply all types of processing. In this case, we just see on this image, I guess it's one of the minimum temperature like first image, and then we specify visualization parameter, and then you can then after that just inspect this data, or really define pipeline where you do process and analysis on this imagery and export it as tables or as just base maps generated in your script. And here jumping into another example, looking on the urban area changes, where you would want maybe to monitor construction areas, determine, let's say, time when construction started or stops, or any type of events or markers in time or space. So detect these areas, map them. That would be another kind of type of spatial temporal analysis. And of course, it's images that we have from satellite data sources. It could we have many images or data sets from multispectral so-called satellites. Some of them they're using based on radar satellite imagery. So you see this few examples below, so coming from Sentinel-1. So it's really, you have a lot to choose from. So here, another quickly going into next examples, looking at agricultural analysis. So this is probably category where we have most of the users using the Google Earth Engine, because if you want to monitor crops, you really have to do analysis on per field basis, detect fields, detect maybe phenology, so do temporal analysis like harmonic fitting, regression analysis. So it's like basic remote machine learning algorithm, or even like sometimes call AI models hosted in AI platform. So we have integration between Earth Engine and Vertex AI, so you can run more sophisticated models there. And yeah, typically when in agriculture, when you do analysis, you want to monitor state of crops, maybe how much water content you have there, moisture, and really detects these temporal changes when there is a harvesting happening or what type of crops you grow at these different locations. A few more examples moving on here. One example focusing on the forest fires. So in some cases, for some areas, you have satellites which observe Earth every 10 minutes. So you might have even get near real time, or it is almost real time, maybe with 1 hour delay, latency, you will get data available in Earth Engine for processing. And so this example basically shows a few images, how the fire would look like in this type of imagery, detecting pixels where fire was high temperature anomaly was observed, and also looking at the same area with more low frequency but higher resolution, let's say the spatial resolution images. So you can really get very detailed maps of where which were impacted by fires. The same goes on for floods. So if you look at floods, there probably you would want to analyze let's say detect flood impacted area. So on the upper right corner, you see example of how this looks like when using Sentinel-1 radar satellite imagery. But of course, if your task is really you want to predict maybe floods, then weather data becomes very useful. So we currently included few data sets which are operationally produced by Google, something called Weather Next. And this data sets, together with probably 10 other different models, weather forecast or analysis models, it's something you can use to really build your maybe flood prediction models and then compare your model results to what you see actually in satellite images. And of course, wrapping this in dashboard, which makes these tools or algorithms more accessible. So in the, let's say, right lower corner, you see example of dashboard built by CARTO. That would be like end user interface that can be accessed by many users who cannot code in Google Earth Engine. And just very quick, switching from presentation mode and jumping into the script. So you see this animation showing weather forecast data. In this case, it's from GFS model. So I just wanted, before giving, let's say, room for Helen to show you example how this looks like coding in this environment, in web-based development environment. So you basically have to write this code in Python, JavaScript, or copy-paste. And this is not easy. So when you start from scratch, so there is some learning curve involved. But once you can write the script, you can then start adding different types of inspection tools in time, space. So here you see one marker that I just drew on the map. And when you run the script, then you can also add, let's say, script lines, which would add different like interface, user interface components. So here showing charts for this specific point, visualizing wind speed or precipitation on temperature, how it changes. And also, let's say, showing different image vector or raster layers on the map. So it's kind of simple, lightweight GIS in the cloud, but we're not positioning this system like as a replacement of existing GIS system. It's mainly meant to develop this type of scripts. And then going back to last slide from my part is if you look at Google Cloud in general, so Earth Engine, I mentioned that we started integrating it into Google Cloud next to other tools. So some tools or services worth mentioning here, which belong to what we call geospatial analytics stack in Google Cloud, is, for example, BigQuery. So Helen will talk much more about this part. So that's our data warehouse, which also supports geospatial data. And CARTO is really one of the solutions that provides an easy way to work with this data stored in BigQuery for many years. And we have also a platform like Vertex AI, where you could also run some more sophisticated geospatial models, as well as Google Maps, where we have like a lot of Google's first-party data that become more and more accessible, available also for analysis using these different platform. So this is more or less our kind of Google approach to address this big geospatial data processing in the cloud. And I think with this, I will give floor to Helen.
Amazing, thank you. So many amazing cool maps on that. I feel like I've definitely got my new desktop background sorted. I'm just going to really seamlessly switch screens now. Hopefully this will happen really seamlessly and everything will look absolutely fine. Jenna, can you confirm if you can see my screen, please?
Yes, it
Yes,
looks great.
perfect.
There is a big M
Great.
in the middle.
Big Zoom US, get rid of that. Okay, fantastic. Thank you. That was just as seamless as I planned. So when we first started talking about what we had planned for this webinar, something that I really, really wanted to talk about was a sort of low code alternative to accessing Earth observation data. I think lots of people are kind of shy away from working with Earth observation data, particularly at scale and particularly when it's in real time, because they feel like there's a real learning curve and a real coding requirement needed to be able to access that data. And I think while in the past that has been true, it's not necessarily true anymore. And that's what I'm going to be talking to you about today. Before I get into that in more detail, I just want to do a bit of an introduction to CARTO and what our SaaS platform is and what that means, because I know there's lots of people here who might not be familiar. So to go sort of right back to the beginning and talk in a sort of philosophical sense for a second, I want to talk a bit for a second about what the ideal data ecosystem is for a lot of organizations. And I think for most people, if it would look something like this, where everyone in an organization who's working with data, no matter what type of data, no matter what type of work you're doing, is all looking at one single source of truth data, typically stored in a cloud lakehouse environment. But actually, for lots of organizations, sorry, their data ecosystem looks something a little bit more like this, which is where some of their data, and very typically it's geospatial data, is siloed, and you're actually working from a different source of truth to the rest of the organization. This has loads of implications in terms of storage costs, because you're paying for storage multiple times. It means that there's security issues with moving your data around. It means that there's risks in terms of the actual results of your analysis, because there's multiple sources of the truth. So this is a real problem for a lot of particularly larger organizations where this sort of siloing can happen. And that is where CARTO comes in, and that's our whole sort of mission, is breaking the GIS data silo. So trying to stop that siloing of location data and bring spatial analysis into the sort of data stratosphere that most organizations are working with. And the way that we do that is with our data platform that is built for the data lakehouse. So what is CARTO? That's our sort of philosophy for what actually is our platform and what do we offer people. Well, the sort of thing that underpins it all is we offer a unified end-to-end platform for doing whatever you need to do with your spatial data to solve your problems all in one place. So whether you're managing the data, you're analyzing it, you're creating these massive visualizations, you're doing sort of AI-driven analysis, whether you're developing custom applications, all of that can happen within one environment with CARTO, all natively in your lakehouse. But I am rubbish at explaining what CARTO is. I'm much better at just showing you what CARTO is. So that's what we're going to do now. We're going to have a look at how we can access some of the really cool data that Gen has been showing us in a low-code environment with CARTO. If you would like to follow along with anything that I am about to show you, please do. It's really, really cool. I know I'm a massive geek and I always geek out at these things, but it is really interesting playing with this stuff. So if you are a CARTO user, you can follow along already. But if you're not a CARTO user, you can head to at.CARTO.com and set up a free 14-day trial. It takes about 30 seconds. Hopefully a link to this will magically appear in the chat any second now. The only other thing that you will need to do to follow along with this is to install the Google Earth Engine workflows extension, which I will show you how to do as we get going. So I'm going to come out of our slides and get on to the live demo. Let's hope my Wi-Fi is up for it. So hopefully you can see that I have now switched to the CARTO workspace. So when you do sign up for that CARTO account, you will land in here, this is the CARTO workspace, and this is where you can do everything that you need to do, all of that stuff I was talking about, the analysis, the visualization, all of it in one place. Generally, when you sign into the workspace for the first time, the thing that you'll want to do is head to your Connections tab and set up a connection to your Cloud Data Warehouse, like BigQuery, which you can do from the Connections tab. It takes about 30 seconds. It's really, really straightforward to do if you can remember your password, which is always my biggest problem. And once you've done that, you are natively connected to Google BigQuery, and you can get going with your analysis and visualization, and everything is happening in Google BigQuery. From there, you can access all of this cool, fun stuff that I unfortunately don't have time to go into today. We're going to be mostly focusing on workflows today. So workflows is our low-code tool for running spatial analysis. Where it really shines is helping you to sort of automate those really repetitive processes by helping you sort of build these automated pipelines, essentially. So we are going to build a workflow together and bring in some of that cool Google Earth Engine data that we've been looking at earlier. So I'm just going to head over here and select Build a Workflow. And I'm going to use the CARTO data warehouse, which is just a small instance of a Google BigQuery warehouse that contains all sorts of demo data and stuff like that. Everyone who signs up for a CARTO account will have access to this. So you'll be able to do everything that I'm showing you. So this is what a CARTO workflow looks like. It's very intuitive, so I'm not going to give you a tour of everything and what everything does, but a couple of things to be aware of. First of all, we have our sources. These are basically your data sets and tables. Then we have our components. These are all of the sort of individual tools that you can string together to build your pipeline. And then we have our canvas here. And we basically drag and drop sources and components onto the canvas to build that pipeline. So the first thing we need to do, like I mentioned, is to get the Google Earth extension package up and running. So the way that we do that is we move down here to Manage Extension Packages. And we'll go to, you can see there's a few here. You can also actually upload and create your own, but we're just going to work with an out-of-the-box one for now. We're going to go to the Google Earth Engine extension, and there's all sorts of information here about the tools that are available. For the first time when you come into this window, there will be a big button saying Install Extension that takes about 30 seconds to install. I've already installed this, so I don't have that button, but you should see that, and it should be very simple to install. I'm just going to go here and go to Showing Components panel, so we can see the components that are available for us. So there's really two types of components that we have available in this extension. We have our sort of off-the-shelf components, and then we have our more customizable components. So for the off-the-shelf components, we have Get Elevation, Get NDVI, which is the normalized difference vegetation index. We have Get Precipitation, and those are basically components where you can do absolutely no coding at all and use that information, use those to access information from Google Earth Engine. We also have Summary Region and Summary Table, and these are the more customizable elements that you can drop bits of code in to get a bit more of a custom edge to what you're getting from Google Earth Engine. We're going to be working with Get NDVI initially, but we will be using Summary Table again a little bit later. So don't forget that one. Get NDVI, this basically we'll use to give us a normalized difference vegetation index, which basically indicates the sort of intensity and health of vegetation. So we're going to be using this to get the NDVI of counties across the USA. So first of all, we need to get our county data. So sorry if my mouse is moving, I'm moving my face away from the bit of the workflow that I'm working in. So let's switch to sources, and I'm going to go into connection data and demo data. You'll all have access to demo data when you log in here. Go to demo tables, and I'm going to search for my USA counties data. Here we go. And then what I want to do is just filter this to just a few counties, just because this is a short webinar and I don't have time to process the whole of the US. So we're just going to go into here. I'm going to go simple filter, and I'm going to filter where the state is New Hampshire, because I happen to know New Hampshire only has 10 counties, and I'm just going to run that workflow. And all of this is happening inside your Google BigQuery data warehouse. So everything happening natively in there. Your data is not being moved anywhere else. It's not being cached anywhere else. Fully stays within your data warehouse. So you can see that's turned green. So we've filtered that data. I can have a quick look in the preview. Let's preview the map and just check that. Then we have this very long tool state, very interesting. So that's our simple filter. And then now all we need to simply do is connect to our NDVI. And let's just select the NDVI. And then we just need to input a date range that we are interested in. So I'm going to just look at all of January last year, 2024. So input the date range, and I'm going to select run. And I think this should take about 40 seconds or so to run. This is very, very high resolution data, and it's basically looking at data for the whole world, all time periods, and just aggregating it for those states and that data that I'm interested in. Something that is really great about workflows is you can see what I've been doing. You can sort of run it bit by bit to help, so you can sort of do your analysis bit by bit, or you can run it all in one go right at the end, and the results get cached as you go. So you're not rerunning the entire workflow every time. So my simple filter, for example, is not getting rerun. Another great thing about workflows is you can integrate it into your wider analysis. So you can, for example, schedule workflows to run every day, every hour to get that sort of real-time data. You can trigger with an API, all sorts of things like that. We're doing something quite simple here for now. So you can see this is turned green, so that means it's run. So let's go ahead and preview the data. In here, if we move right along to the end, you can see we now have this E NDVI column, and this is basically our NDVI value. So a larger value means that the vegetation, there's more intense, probably healthier, different types of vegetation available. So I'm just going to switch to, so we can take a look at this, so it's not just numbers in a table. Let's just switch to map, and let's quickly create a map. And we're going to, just for now, move to a different part of the CARTO platform, which is CARTO Builder, which is our sort of mapping dashboard visualization part of the platform. You can see our data set has loaded in here. And I'm just going to do a quick bit of styling just so we can make a bit of sense of this data. So I'm going to change the fill to be determined by that NDVI. And let's just change it to become more green because we're talking about vegetation. And then I'm going to quickly set up a pop-up. You can see how quick and easy it is to set up maps in CARTO Builder. It's really, really intuitive. Let's just set a pop-up here. And now every time I click on any of these counties, oh, that's a long number. Let's just change the formatting so it's a bit more readable. Every time I click on any of these counties, we can now see the NDVI. So now we could go and share that with whoever we needed to in our organization or with the public, and they can start to go ahead and use this analysis to start making decisions. And we've done all of that in about 5 minutes, which is fantastic. This is obviously a very simple version of how you might employ this type of data. So let's go ahead and look at a slightly more complicated example. So this is exactly the same sort of process, and I've created this in exactly the same way, but here we're looking at NDVI data for, I actually can't remember the name of this county, but it's NDVI data for it's not a larger area, but it's much more detailed. You can see I've added these sort of dashboard elements to the edge of my map. We call these widgets, and they're really great ways of helping people to understand the data they're looking at. So you can see we've got this number of features here. So I'm showing now 172,000 features on this map. And I can use these dashboard elements to help me sort of make a bit more sense of the data. So for example, I can filter to month here. I can explore this histogram. I can say, maybe I only want to have a look at NDVI values from summer by filtering like so. And we can see we have much darker values because there's much more vegetation in summer. Or maybe we want to filter to winter, and we should see the opposite. There we go. So this is just a slightly bigger, slightly more advanced example of what we built out together earlier. Before we finish, there's one final thing I want to show you. We're going to move away from NDVI and vegetation now and start to think a little bit more about climate and risk, and start to think about how we can not just have this data and visualize it on a map, but how we can bring it into our sort of wider pipelines and integrate it in our analysis a bit more. So which of these many tabs that I have open am I interested in? This one. Fantastic. I had ordered these logically. So this is another workflow that I built earlier. And what this is doing is, let me paint the scene. So let's imagine that we work for an insurance company. and we insure properties across the state of Texas. And there's recently been loads and loads of rainfall across Texas. And so we have a number of properties that have said, my property's been damaged. I want to claim insurance. And we want to work out, are all those claims genuine? Or are some of them maybe fraudulent, or some of them twisting the truth a little bit? It's a common problem that insurance companies have. So rather than have to go through those claims one by one and have a look at the sort of local information one by one, flipping through a report, we can use Google Earth Engine in conjunction with other datasets to be able to do that at a much greater scale. And that's exactly what we're doing here. So I won't talk through what every stage of this workflow does, but I'll go through it sort of bit by bit. So this first stage is just a bit of pre-processing. We have a list of 10,000 properties here that I must stress, by the way, all of this is fabricated data apart from the Google Earth Engine and flooding data. So no properties in this are real in any way. They're just random points on a map. So these are our properties, all of the properties that we insure, all 10,000 of them. We also have down here 888 properties that we are saying are claiming due to flood damage. So those are our sort of source datasets. What we're also going to look at is 2 indicator datasets that we'll use to help work out, could these be fraudulent claims? So the first one is data from Google Earth Engine. So here we're using, from that Google Earth Engine extension, the summary table component. And you can see here, we're able to actually add in a bit more customization than we were with that NDVI component. So we're able to add in a bit of a query. I did say this was the low code portion of the webinar, so it's not no code. So there is a little bit of code here, but it's not too much. You can basically see here, we're calling this image from Google Earth Engine, and we're basically filtering the date period that we're interested in, and we're filtering a sort of bounding box that we're interested in to Texas. We're saying which band from this image are we interested in? So we're interested in PR, which is precipitation. And then we're also looking at the aggregation or reducer function and the scale. So what this is doing is essentially telling us what is the maximum daily rainfall for each of those properties in that time period. So that's one indicator. And then the second indicator is a data set we've sourced from somewhere else. This is basically flood risk data at a county level. So if we preview the data here, we can see that we have all of our counties, and we have these 2 risk scores here. We have coastal flooding, which is a sea flood risk R field. I always love the name of these fields. And we have river flooding risk. So what we can do is we can bring these 2 data sets together, combine them with our claims data, which is exactly what we're doing here, and say if the rainfall was low, and if it's in a low risk area for flooding, then it's very unlikely that there was actually flooding there. So we might want to look into and request a bit more evidence for that claim before just going ahead and processing it. So with all that analysis done and all of those disparate data sources brought together, we end up with something like this. So this is another map that I built earlier. And these points on the map are our 888 claims that we have. And we've graded them by total insured value by their potential fraudulent claim risk. So these sort of dark pink values here are high flood risk, high claim risk. Let me just filter by those. And if we zoom in and take a look at some of these individually, let's maybe go for this nice big one here. Again, these are all absolutely fictional, so apologies if any of you on the call happen to live in this location. I'm in no way accusing you of anything. If we open a pop-up for one of these points, we can see why this might be flagged as a high claim risk. So here we can see it's in an area not applicable for coastal flooding, relatively low river flooding risk, and the maximum daily rainfall is only 1.9 millimeters, which is, absolutely nothing. So we might be able to say, great, we can have a look at these high risk areas and maybe say to them, can we have a bit more evidence, maybe photographic evidence or whatever it is you need to prove that there has been genuine flooding damage. On the other hand, if we just zoom back out and let's look at the other end of the scale, let's look at negligible. So these areas which have been flagged as very unlikely to be a fraudulent claim. Let's zoom in, lots around Houston. Let's take a look at let's take a look at this one. Okay, this is very clearly not a real property, but it's just to illustrate. If we open this here, we can see we have a fraud claim risk level of negligible. And that's because we have a high maximum daily rainfall of 26.4 millimeters. And while there's not applicable coastal flooding risk in this area, we can see that the river flooding risk is relatively high. Actually, we're right next to a river, so that makes sense. So these negligible flood risk claims, we could probably save quite a lot of time by not sort of going back and forth and requesting more evidence. We could probably just say, go ahead and go ahead and process these, and not sort of need our analysts to look into one in lots and lots of detail. So that's how you can bring together lots of different sources and bring Google Earth Engine data into your sort of wider workflows to help you sort of solve the problems that your business has. The final thing that I did quickly want to share before we conclude is that some of you, if you follow us on social media, you might have seen that a few days ago, in fact, last week, actually, no, only a couple of days ago, we launched our CARTO AI agents, which is basically you can now integrate AI into your maps to help you with everything that I was just doing, all of that data exploration. You can now use AI to really help you with that. So if we just open our AI agent here, in the interest of time, I'm just going to use one of these prompts that I've already set up. So we have a prompt here that is, what percentage of claims by total insured value are almost definitely genuine? So rather than me going through and interrogating all of that data myself, I can just ask the AI agent and it can go through and look through all these widgets and look through everything I set up and say this. Negligible fraud risk claims represent 39.9% of total insured value. It's telling me what the low fraud risk is as well. It's combined those together, and that's a bit easier than me sort of going through and exploring all of the data myself. Is using that AI agent. This is available in all CARTO accounts now. So if you want to try this out, then you absolutely can, and it's a really, really cool tool. I definitely recommend it. So that's the end of my live demo. That was the last thing I wanted to show you. I just wanted to conclude by talking a little bit about CARTO and Google and how we work together. We've obviously been really focusing on Google Earth Engine today because that is the topic of this webinar. But the CARTO, that's just a small sort of piece of the puzzle of the Google CARTO architecture. There's so much more that our partnership offers you. There's just a sort of quick representation of it here. Things like app development, you can integrate with Google Maps, with Gemini. There's all sorts available for you here. So if you are interested in learning more, please do get in touch. And that is actually everything from myself. Let me just stop sharing my screen. And I believe I have talked for a very long time. Apologies for that. But let me just take a quick look and see if we have time for a couple of questions. Genna, any closing thoughts for you while I have a quick look for these through these questions?
Yeah, so while you were presenting CARTO, I took some time to answer a few questions. They were mainly Earth Engine related, and I see we have questions coming. So the first one, I see it's again Earth Engine related. The Gennadii, thank you. Yes, you're welcome. I don't have any specific indices. I think there are some of these packages you mentioned. There is one implementation of one of the drought indices, but that's probably it. I think that for this type of questions, there is also very vibrant Earth Engine community forum available, which you're probably aware of. So I would probably suggest to kind of ask this more detailed question there. Yeah, I think that's hopefully answered live. And yeah, I guess Helen, next question is probably
Yes.
more, if you can take this.
Yes, fantastic. Thank you. So the next question we have is, we have the challenge of data in different coordinate systems. Can CARTO reproject data? So something that I didn't show you today is that, so CARTO, when you're, like I was showing you, when you're visualizing data and you're using CARTO Builder, it's a world map. So like with most interactive world maps, we work in WGS84. But as part of the CARTO platform, we have an import UI, and that will basically, when you import data, that will do the reprojection for you. So the answer is thank you for the question. And then next question is, how did the cost of CARTO get combined with costs for Google Earth Engine? Costing is basically you're only paying for consumption once. So that's one of the great things about working with a cloud native platform like CARTO is you're not paying for any sort of consumption with CARTO. That's all happening with Google, with your Google BigQuery account or whatever it is you're using. But we also obviously do have there's a cost implied for licensing with CARTO as well. That there's a few different tiers and seats that I won't get into on this. But if you are interested, you can, like I said, you can set up a free trial with CARTO that lasts 14 days, or we also have a request a demo option. So if you have more questions and you would like someone to talk through a little bit more about what your potential use cases might be or anything you want to learn, then you absolutely can. Oh, and I can see our moderators just dropped a link in the chat. Thank you very much. So I think that's all the questions done. Thank you so much, Genna, for answering the questions as we go as well. That makes things easier. But if you do have any questions, you will be sent a link to, probably tomorrow, you'll be sent a link to these slides and links to the maps and stuff that we showed you. In there will be a sort of contact details if you want to reach out and have any more questions. But I think that's everything from us. So thank you so much for joining. I hope you found it interesting. I hope you learned something. Maybe there was something cool that you have taken away from this that you want to try. And yeah, please come along to another webinar soon. Thank you.
Thanks, everyone.
Thanks, Genna.